we're going to continue with functions. So guys, we're back up here. So we're continuing with functions, which is what we were talking about on Friday, right? Friday we were practicing not only the different representations, but taking a relation and deciding whether or not it qualified as a function. So what were the different ways or representations that we could use for our relations on Friday? What did we say, Mason? A table. What else?
The two circles.
A mapping. What else did we say on Friday? A what? I'm just not hearing what you're saying.
Listing it.
Huh?
Listing it.
Oh, like what type of list? What did that list look like? Alright, so ordered pairs.
Maybe graph.
A graph. Okay, and then we said we could talk about some specific pieces about it. Like what did we say with the X? What else could we call the X?
Domain.
Domain, and how did we list a domain?
In numerical order with no repeats and
Right, in numerical order with no repeats, in braces. Okay, we said the same thing with the range. No, you're totally fine. I just wanted you to actually have it. Yep. Yep. We talked about an inverse. An inverse is where we flipped the X and the Y. How often did we say a relation is a function?
Never.
Sometimes, right? A relation is sometimes a function. When is a relation a function?
always.
Wait,
No.
That's the same thing.
When what's this?
The
Wait, I thought that's
when
just.
the X
When the X repeats.
When the X value does not
Not
repeat,
does
right? A relation is a function when the X value does not repeat or it passes the vertical line test. Okay, how often is a function a relation?
Always.
Always, right? A function is always a relation. A relation is sometimes a function, and it's sometimes a function when the X value does not repeat. Now, there is one representation that a function gets that a relation does not. So we can't use this representation for any relation. We can only use this representation for a function. Okay? And it is a function rule or function notation. And that's what we're going to be looking at today. Because oftentimes a function is going to represent something that has a ton of values. Okay, in fact, there are so many values that there are an infinite number of them. And so we don't want to have this possibility of like, okay, if I want to know what happens when x is 2, now I have to open this million-page textbook and find the table where x is 2 and see what its y value is. I mean, that's just ridiculous. Right, so a function rule contains all of those values in one teeny tiny rule. Evan, can you put your hood down for me? So if we have something like y equals 3x plus 4. Okay, this is a function rule. Okay, it tells us that x is going to be our input and y is going to be our output. And usually a function rule is something that students have seen before. Okay, a function rule is something usually they've talked about. It's the function notation when we make that jump here in a minute. Okay, so Gavin, what's your favorite number?
0.
It's 0. Okay, so Gavin says his favorite number is 0. So x equals 0. So Gavin wants to know what y value gets paired with 0.
0.
Okay, so we are going to take this x value and we are going to plug it in for x. So to find the y value, we are going to substitute 0 for x. So we'll now say, okay, well, y equals 3 times, but instead of x, what does x now equal? 0 plus 4. So 3 times 0 is 0. 0 plus 4 is 4.
Y equals 4.
So y equals 4. We could then take this information and choose to represent it in any variety of formats. So maybe we decide that we want to represent this information in a table. So when x is 0, y is 4. We could represent that as an ordered pair. 0, 4. We could plot the point. 0, 4.
So when x is 1, y is 7?
Okay, so Cade, what's your favorite number?
25.
25. Okay, so Cade says, well, I'm curious about 25. So now instead of saying y equals 3 times 0, I'm going to say y equals 3 times 25 plus 4. Good, and so now we'll say 75 plus 4. Y equals 79?
Yes.
Okay, so when x is 25, y equals 79.
Oh my gosh.
Mallory, what's your favorite number?
32.
32. Okay, so x equals 32. So now we'll say y equals 3 times 32
Magic.
plus 4. So when x is 32, y is 100. How many times could I ask people their favorite number?
Infinite.
For forever, right? And luckily everyone in here picked pretty reasonable numbers. No one picked like 14.27153800000000049. Whatever. You could pick like totally ridiculous numbers and plug those in too. So this contains all of those input and output values. Now, is it really realistic to just have this function floating around? I mean, no one's going to come up to you on the street and say, can you tell me y equals 3x plus 4, what the y value is if x equals negative 72? Right? But instead, it's how much money would a business make if 40 people came? What happens if 70 people came? What happens if 1,000 people came? Right? And it keeps all of that information in one little nice list so that we don't have to write them all down. Does that make sense? Now, a function rule is kind of like flying coach. I mean, it does the job. It tells us our x and y value. But function notation is our first class. Okay? And function notation, we replace y with this. Anybody know how to read this?
F of x.
Mitch, what is that? F of x, right? So this is f of x. Now, f and x are sort of dummy letters that we just fill in there. It doesn't have to be an f and it doesn't have to be an x, but those are generic because this is a function of x. Okay? F of x and y are the same thing. Y is the coach version. F of x, function notation, is the first class version. Now, we can blame old dead men for this too. What do parentheses mean in the math world? Multiplication. What does the word of mean in the math world?
Multiplication.
Multiplication. This has nothing to do with multiplication.
What?
It's not multiplication.
How dare you.
Okay? So here's what's going to happen. Now instead of having y equals 3x plus 4, we are going to have f of x equals 3x plus 4. I literally just replaced the y with the f of x. Okay, so now when we want to find something, Evan, what's your favorite number? 13. Now we're not going to be looking for x equals 13. We are going to say we want to find f of 13. This says evaluate the f function when x is 13. Okay, evaluate it for x equaling 13. We're going to do the same process, so I'm still going to take this 13 and plug it in for x. have this problem solved, I have all of my information stored in one chunk. My x value is 13, my y value is 43. Okay, when I had it as a function rule, okay, my y value is 4, but I had to go back up over here to find my x value, or I had to write it in another format to find which x and y went together. In function notation, I have that x and y paired up nice and neat for me from the get-go. Okay, it also allows me to work with multiple functions at the same time, which is the more real-world application. Okay, so let's say we want to go rent a car. Okay, and they have choices of a compact car, a mid-sized car, or a luxury car. Is that what they call it? I don't even know. Whatever. So we have compact, mid-size, or luxury. Is it going to be the same price no matter which size car we rent? No, right? There's going to be some different type of function for how many days you represent or how many days you rent each different size car. So maybe we have a function for compact, a function for mid-size, and a function for luxury. Okay, but they all can be based on the same thing, like the number of days. Okay. We are going to get a little bit more to that extreme piece as we go, but right now we're just going to stay on the simplified version and not necessarily worry too much about that real world piece quite yet. But let's say I have something like f of x equals negative x plus 5, and g of x equals x squared plus 5x. I mean, these aren't going to be realistic for renting a car, but whatever. Right? We get the idea that we have two function rules that are going to be important at the same time. Two things that we want to consider.
So can it be any letter except for x? So f of x, g of x?
Well, I mean, yes, but it also could be like x of t, right? So maybe our variable is time, and so the letter we want to have in here is t. Okay, and we will get to that later this week. So they are just truly dummy variables. Okay, we just tend to start with f of x, and we tend to use x as our input. They've already done trinomials where a does not equal 1. Okay. Yep. Trinomials where a does not equal 1 and they've already, or where a does equal 1 and they've already done trinomials where a does not equal 1. Yeah, perfect, no problem. Okay, so let's say we want to find f of 5. Okay, what is this asking us to do? If it says find f of 5, what do we need to do? Plug in 5 for x. Where? Into all of them? Do I need to plug that 5 in over here? Why not?
Because it's a different cause.
Right? This is the f function, so it says evaluate the f function for 5. So do we see how having that letter there allows us to sort of, it's that first class, right? It's a little bit fancier. So we're going to plug this 5 in for x. So now instead of saying negative x plus 5, I'm going to say negative 5 plus 5. And so what will f of 5 equal? How about g of negative 4? What do I want to do to evaluate g of negative 4?
Plug in for x.
Where?
X squared.
Okay, so I want to plug that negative 4 in here.
Yeah, and with 5x.
And at the 5.
And over here. Okay, so you guys give me an answer. Figure out what that is. What do we get, Lucy? -4. Did we get anything else?
No, I didn't.
Any -36ers? Okay, so we have to be really careful on this one. When we plug in this -4, what do we have to make sure we do?
-4 squared, so it's -4 times -4 and negative.
And if you're putting that in your calculator, how do you need to put that in your calculator?
Negative.
-4 squared.
If I type this into my calculator, will this give me the correct answer?
No.
Why not?
-4 times negative. Does it give you -16?
Because it gives you -16. Why does it give us -16?
Because it's wrong.
Squares are
Oh, squares are positive?
Yeah, why is our calculator telling us -16 if we type this in? We've talked about this.
because it's all like the order you put it.
Order of operations says exponents first, so this is really squaring 4 and then making it negative. So if we type it into our calculator, we have to put that -4 in parentheses. Okay, so I tell my students this all the time. If you're not sure, put the parentheses there. Most of the time, like, ooh, I can think of very, very rare, like, just put the parentheses. You'll be wrong if you don't have them. You'll probably just be fine if you do have them. Okay, so we want to make sure we're doing -4 squared because that then makes it a +16. Oop, that's a G. So we'll get G of -4. -4. Okay, so then what if I ask you this one? F of 7 plus G of 2. What are we going to do on that one?
Field goal.
No. Any thoughts? Mason, what do you think?
Plug both into the equation and add the two answers.
So what would you do first by your definition, or what you're saying there? What would you do first?
Solve f of x equals -x plus 5 by plugging in 7 x.
So find f of 7 first. And if we find f of 7, we'd say -7 plus 5, which is -2.
Wait. Oh.
And then find g of 2. So to find g of 2, we'll plug this 2 in for the g function. So 2 squared plus 5 times 2, so 10, 14.
So you get 12.
And then we'll add them together. And so we'll get an answer of 12. Do we see how this works? Okay, so you can just